Welcome to a KNAUER HPLC columns tutorial on the topic chiral stationary phases. So maybe you already watched some other KNAUER HPLC column tutorials and you're familiar with this little chart explaining the difference between the silica gel and the polymer gel based columns that KNAUER can offer. And when we are talking about chiral stationary phases, or CSPs as they can be called, they can be ordered here, so they are silica gel based phases, but still they do not really fit into this family. So chiral separations and chiral phases are something very special, and they are produced very differently, and they are really used for a typical kind of application. So this is why we did a separate video for this, because just to let you know the difference. But first of all, what is a chiral separation? Maybe you're not so familiar with it, and I just wrote down for you that chirality denominates the fact that there are items which act like an image and a mirror image, but they can't be brought to congruence along an axis of reflection, although they are similar. So most often this little picture of your hands is used, and it perfectly describes what happens in chirality. So a molecule that would look like your hands has the same some formula. So if you do a 2D drawing of this molecule, it would look the same. But in 3D, it's not the same. So it's just the steric configuration that is the difference. And you can imagine that this is for HPLC separation a really hard task, and that classical HPLC with reversed phase or normal phase really gets does not work here. So there have to be really special columns for that and special methods developed for chiral separations. We have different types of chiral columns. And this is just a little overview of our USphere2 chiral modification types. And they can be divided into two different groups. So there are the polysaccharide-based chiral stationary phases, and there are also some immobilized brush-type phases. And I just want to go shortly through that and explain you what it means and what the difference between these phases is, and maybe when you can use which phase. So let's start with the polysaccharide chiral stationary phases. These are also the most often used phases on the market because they have, they are really good in chiral separations. So when you produce them, you take a silica gel particle. So it's not very different from the silica gel particles that you use for reversed phase HPLC, for example. But now you make a coating. A polysaccharide is coated on that silica gel particle. And when we talk about coated, we mean really it is only coated. It is not covalently bound, so it is not a very stable phase. The disadvantage is that it is not very stable, so you have to be careful with the elements you choose. You can't use any element on these chiral phases because they are that unstable. But the very, very, very good thing of that is that because of this coating, you have a really good steric separation, because in a covalent bound, it would be really fixed. And here it is some kind of soft and really well made for this, separations. The polysaccharide itself is again modified with a special chiral selector. And here it is called just R for a rest group. So overall, we call the polysaccharide, including this little group, the chiral selector. And in the end, both of them, so the polysaccharide type and also the type of the chiral selector, define the selectivity of the phase. So you can have different polysaccharides and also different chiral groups in the end that define your phase. What KNAUER offers is USphere2 Chiral OM phase. And here you have a chiral selector that is bound with a cellulose material on the silica gel particle, and we have the Eurosphere 2 Chiral AM. And the only difference here is that we use amylose phase and not cellulose as the polysaccharide. The selector is the same. A quick look at the characteristics. So you see we use silica gel in a spherical form, very pure, really the same as for our Eurosphere 2 material, but we have here a large pore size. And you need this large pore size because you need this room for the chiral separation. So the steric selectivity needs this space. And here, therefore, the base material has large pore sizes. Here the chiral selector is mentioned. So one amylose and cellulose, and this selector is the same. And maybe what is really important to mention, there is a large manufacturer on the market for chiral columns, and to a lot of people the columns from Deitzel are well known, and Eurosphere 2 Chiral AM is an equivalent to the Chiral Pack AD, and the Eurosphere 2 Chiral OM is an equivalent to chiral cell OD phase. So very often it happens that somebody needs a replacement for these columns, and then we can directly offer one of our materials. Also, we offer the Chiral OM and AM for different separation modes. So very often in chiral separations, you work with some natural molecules that are used in the normal phase mode. So they are solved in very unpolar solvents. And then we can offer the Chiral AM and Chiral OM phases. If you're going to work with reversed phase, so with polar solvents like in reversed phase mode, we have special modifications for that. So it is still Chiral AM, but with an R in the end, and OM also with an R in the end. This means this phase is still the completely same chiral selector as here for the normal phase mode, but they are produced with different solvents and a little bit different process. And this gives a little bit different selectivity. So you can imagine if this chiral selector sees in the production process already these solvents and has never seen these ones, selectivity could be a little bit different. And this is what happens here. So the selector itself can be used with both types of solvents, but we do not recommend to flush between reversed phase and normal phase just because here of this production process. Okay, now let's get to the second type. So this is the second type next to the polysaccharide phases. There are the immobilized brush type phases for chiral separations. And we offer here the Eurosphere 2 Chiral NR phase. It's a so-called brush type phase, and it has a very broad generality, can often be used, but sometimes it's not as effective as these coated materials. But a very, very high loadability, and also the fact that this selector is covalently bound has a lot of advantages. So this phase can be used with all common HPLC LONs. You don't have to be that careful. It can't be destroyed so fast. So it is perfectly suited for preparative applications, and also for long time applications because it is so stable. So whenever you can use Chiral NR, I would recommend that because it is so stable. Often it has the same selectivity, so you can reach the same results as with Chiral AM or OM, but it is more stable. But there are cases where really here Chiral AM and OM have a lot better results, and then you will have to stick to them. The characteristics, again, we have one Chiral NR phase for normal phase solvents and one for polar solvents like reversed phase solvents. And here it is again the fact that the production process is a little bit different, but also here the chiral selector is a little bit different. So what exactly the chiral selector is in this case is proprietary, but just let you know that this one is optimized a little bit more for chiral analytes that are soluble in this polar solvents, and this one is for normal phase solvents. So here you can really get a reversed illusion between these both columns for two different modes for the same molecules. Again, it is a silica gel-based particle, spherical, and here you don't need this large pores. And again, this makes this phase a lot more stable because it is also mechanically more stable. You can imagine if the pores are not so big, you can take a lot more pressure on these columns. And again, it is a replacement for the well-known chiral pack IA, IB, and IC columns from the company Deitzel. So whenever you have a method running on these columns, you can maybe try to use also the Eurosphere 2 Chiral NR column. And this is just an overview in the end to compare the three phases that we offer. So on one side here you have the chiral NR and here the AM and OM phase. So very different is what is here the last point. So the NR is very stable in all elements, and for these both phases you really have to be caution. I can just say like it stays here. Caution, it is not stable in all elements. So please familiarize with the care and use of these columns to not destroy them. These both are also scalable in the prep range, and this is ideally suited for that because it has higher capacity, so higher loadability than these ones. And as I told you before, here you can have an inversion of the elution order if you want, if you just switch between the NR and the NRR phase. Here, this is not possible. These are really just two phases for two different modes. What is maybe also interesting is here, the OM and AM phase are really highly versatile, and the AM a little bit more than the OM phase. And for the chiral NR phase, you are a little bit limited, so it does not always work. So we wrote down here the most important thing: your analytes need an oxygen near or at the chiral center, and also an aromatic ring. Otherwise, you can't use this phase. These ones do not have such predictions, so you don't need something very special. You can try them for nearly any chiral molecule. But that also leads to here this NR phase being a little bit more predictable. Okay, in the end now, how can I choose the right column for my chiral separation? I know this is a really hard task, and I can tell you that you have only two chances. Either there is a publication telling you how to do it, in which column they could already do a separation. Maybe you find it on our web page or something somewhere else in a publication, and maybe we have a recommended column for this application. And if not, you will have to try. So we can't really, away from this here, we can't predict anything if a chiral separation might work or not. And this is why we offer a chiral column screening. So whenever you're not sure, when you don't have an application and you don't want to try it on your own because these columns are really cost effective, you can send us samples and we can try this for you. Just talk to us, to our application department, and we will find a way to test for you if your application might work on our column. So this is for any other column, it's not so important to have this, but for chiral columns, the screening service is really important because we can't tell you if it might work or not. So I hope I gave you a little overview over our chiral columns and why they are so different from all the other columns we offer. And if you have any questions on chiral columns, please come back to us.